Processed foods have revolutionized modern life. They promise quick energy, tantalizing flavors, and unmatched convenience, from crispy snacks that satisfies mid-afternoon cravings to a microwavable meal that frees up precious minutes. These foods deliver immediate gratification. They often contain optimal blends of sugar, fat, salt, and additives, engineered to hit the brain's reward centers with a precision, enhancing mood and momentarily reducing stress through a dopamine surge. But if they feel so good, how could they possibly be problematic? Is it truly just food, or are these some packaged goodies below the line between nourishment and dependency? Emerging evidence suggests that highly processed foods, those stripped of fiber and nutrients, then resembled with added sugars, refined carbohydrates, and fats, may trigger addictive-like eating behaviors in susceptible individuals. When combined with a fast digestion and intense flavors, these characteristics create a potent formula for compulsive consumption. Ultra-processed foods now comprise over half of the daily calorie intake in many high-income countries. In the United States, more than 60% of the average diet comes from packaged or ready-to-eat products, while in Europe and the parts of Asia, that figure is steadily climbing. One survey reported that nearly 1 in 7 adults worldwide exhibited behavioral patterns consistent with the food addiction, characterized by intense cravings and continued consumption despite adverse health consequences. Are witnessing in the early stages of a public health crisis driven by engineered hyperpalatability. Much like addictive drugs, certain foods can overstimulate the mesolimbic dopamine system, high glycemic load, carbohydrates, and fats, when consumed rapidly, produce rapid spikes in the blood glucose and free fatty acids. Neuroimaging studies reveal that these surges enhance activity in the nucleus accumbens and orbitofrontal cortex, areas linked to craving, reward valuation, and compulsive behavior. Over time, repeated exposure may downregulate dopamine receptors, requiring ever greater quantities to achieve the same pleasure, mirroring tolerance observed in substance use disorders. Despite elaborate labels, the precise chemical cocktail in the processed foods remains a moving target. Manufacturers blend emulsifiers, stabilizers, flavor enhancers, and texturizers, many of which lack long-term inhalation of ingestion studies. While individual components might be deemed safe in isolation, their combined effects and breakdown products during digestion are largely unknown. Animal models indicate the emulsifiers can alter gut microbiota and promote low-grade inflammation, potentially influencing reward-deriving eating through the gut-brain axis. Despite elaborate labels, the precise chemical cocktail in the processed foods remains a moving target. Manufacturers blend emulsifiers, stabilizers, flavor enhancers, and texturizers, many of which lack long-term inhalation of ingestion studies. While individual components might be deemed safe in isolation, their combined effects and breakdown products during digestion are largely unknown. Animal models indicate the emulsifiers can alter gut microbiota and promote low-grade inflammation, potentially influencing reward-deriving eating through the gut-brain axis. Short-term studies highlight alarming trends. Individuals who report food addiction symptoms often exacerbate higher body mass index, greater insulin resistance, and elevated markers of systemic inflammation compared to those without such symptoms. Behavioral signs include loss of control over portion sizes, persistent cravings, and unsuccessful attempts to reduce intake. A constellation resembling these 5 criteria for substance use disorders. How will lifelong exposure to hyperpalatable foods shape metabolic and mental health? Decades from now, unlike tobacco or alcohol, where the timeline of harm is clear, processed foods are a ubiquitous part of a daily life, making controlled long-term studies challenging. The first large-scale cohort study examining non-obese, non-addicted individuals transition into problematic eating patterns only began recruiting in the past few years. It may be 5 to 10 years before we fully understand the chronic consequences such as cognitive decline, cardiovascular risk, or novel metabolic syndromes triggered by this dietary experiment. Teenagers are especially susceptible. During adolescence, the nervous system matures faster than the prefrontal cortex, lowering impulse control and increasing vulnerability to addictive stimuli. Surveys indicate that youths consuming high proportion of ultra-processed snacks exhibit more frequent binge episodes and higher scores of food cures reactivity measures. Early life habits, once ingrained, are notoriously difficult to modify, setting the stage for a lifelong dependence and associated health issues. Reports of irritability, mood swings, headaches, and intense craving emerge when habitual processed foods consumers attempt to cut back. In a controlled diet trial, participants report significant withdrawal-like symptoms akin to caffeine cessation, including difficulty concentrating and anxiety spikes when deprived of high sugar, high fat foods for even a few days. These symptoms can drive replace, perpetuating a cycle of dependence. Processed foods are undeniably woven into the fabric of a modern life, offering intense energy and flavor on demand. Yet mounting evidence suggests that many of these products are more than mere sustenance. They are engineered to exploit our biological reward system, fostering addictive patterns that jeopardize long-term health. Recognizing the addictive potential of ultra-processed food is the first step toward informed choices, policy reforms, and research investment to safeguard future generations. We stand at the crossroads. Continue down the path of a convenience-filled dependency of a reorient our food environment toward balance, transparency, and genuine nourishment.